here are what we're going to do. I'll give you an example, and then I'll have you one to do on your turn. And then we'll take a break, and we'll come back, and I'll show you how to estimate square roots like I just did. So when you want to find the minimum and maximum, that's the top or bottom of the humps. First, you got to get the derivative. And then we want to find out when the slopes of the tangent lines are horizontal, 0. So we put the derivative function equal to 0. That'll get you the x where that's located. And then to get the y, you put that back into the original function. So once you use the derivative function equal to 0 to find out where the tangent lines have slopes of 0, where they're horizontal, that gets you the x at that point. And then to find the y, you put the x back into the original function. Now to get the tangent line equations, first you got to find the point of tangency. You may be given the xy point, or you may just be given the x. Once again, you find the derivative function. Now this time you got to find the slope at the point of tangency. You don't know what the slope is when you're finding the tangent line equation. So you replace the x in the derivative function to get the slope, and then once you do that, you can use point slope form, which is, maybe you like to do y equals mx plus b, but I tend to show point slope form. Okay, so I'm just pausing for about a minute. I'll try not to go too fast. Okay, so I'm going to give you an example of how to find the minimum and maximum, and then also find a tangent line equation based upon some information about the tangent point. Okay, so let me take a sip of water. I'll give you an example, I'll have you do one on your turn, and then we'll take a break, and I'll finish up today. I'll show you how I estimated that square root. Okay, so here's the example. Our original function and what we want to do is, again, exactly what was pointed out earlier. We want to find the minimum and maximum, or the top and bottom of the humps. And then when x is 1, we want to find the tangent line. Okay, so I'll just pause for a moment, and then I'll go through this example, and then I'll give you one to do on your turn. Okay, so here's visually, it's just a sketch, arbitrary graph. And so we got 2 points, one on the bottom hump on the right, the other on the top hump on the left. So we're going to find those. Then we're going to find the tangent line that crosses the graph at a point where x is 1. So that's kind of a visual of what we're doing. Okay, well, first we got to get the derivative. We want to find the function that gives us the slopes of the tangent lines. Okay, so 3 times the 1, subtract 1 from the exponent. 2 times the 3, subtract 1 from the exponent. 5 is constant, so it has a slope of 0, so we don't have anything else. Okay, so now what we do is we want to find out when the slopes equal 0. That would be when we have a horizontal line for the tangent line, and there's 2 places where that occurs. Okay, I hope the GeoGebra simulation helped that understanding. So now we just put this equal to 0. Now I made this so that you can use the zero product property. So when I give you one to do on your turn, that's also going to be the case, right? And I made the problem more manageable that way. Okay, so now I'm going to factor out the 3x. Oh dear. Okay, so now we got two locations because we got two things multiplied. So one is when it's 0, that's right here. And the other is when it's -2, that's over here. So we got x is 0 or -2. Okay. Now we want to find the y values at that location. Well, we got to get the y values from the original function. Remember, the derivative is the slope of the tangent lines. It's not going to get you the y values. We put the derivative equal to 0 because at the humps we have horizontal tangent lines, which means these slopes are 0. That's why we're doing this. Okay, so now finding the y's. Replacing it into the original function. All right, so I'll just simplify this. This is going to become what? -8, 12, and 5. So I get 9. Okay, so then 0, 5, and -2, 9. So that's what these are up here. This would have been 9, and this would have been 5. Okay, and you know, so that's kind of helpful. If you had to make the graph, now you can be a little more accurate beyond just sketching. Right, and if you wanted to find the area from this hump to the left, you can do that now. All right, before I go over the next step, getting the tangent line equation, does anybody want to ask anything about that?
So first step from the first into the second, I'm still not quite clear on like how you're getting from step 1 to step 2, like what you're taking out of the equation.
Do you understand how I got the derivative?
Okay. Yeah. So then when it goes into the next couple of steps. Okay. Oh, so okay. Thank you. Sorry.
No, you don't
wasn't quite sure of the.
You don't have to apologize. I asked if anybody needed anything. That's why. I want you guys to ask. Okay? That way we make sure clear, because this is new to you. And, you know, I could be the most awesome explainer ever, which I doubt is the case, but that doesn't mean I address your issue.
Is this going to be on the test?
Well, I showed you what was going to be on the quiz, right? And this was not part of that, right?
Sorry, I couldn't remember.
No, that's okay. No. Let me make it simple. No. No, please ask. I don't mind. Doesn't bother me at all. Okay, so I'm now going to go over the tangent line. I kind of pointed it out to you on the GeoGebra just so you can kind of get an idea without all this verbal stuff, without all this math in your face, right? So what we want to do now, when x is 1, that's the point on the graph. What's the equation of the tangent line at that point on the graph when x is 1? Well, notice we got to find the y value at the point. We don't know that. Wasn't given to us. Okay, so for the tangent line, when x is 1, we need to find the y first. All right, well, we go back to the original function to find the y when x is 1. All right, and so what, 1 plus 3 plus 5, so it looks like 9. Okay, so then 1, 9. And so this point right here is also 9. Okay, so the top left hump is the same as the y over here when x is 1. All right, so now we know the point our tangent line is crossing. We know our tangent line is crossing at 1, 9. In order to find the equation of the tangent line, we need to know the slope. Here's our derivative function that will give us the slope of the tangent line for whatever x. So now we just got to replace the x in the derivative function with 1. So the slope when x equals 1 . Okay, so this is going to become, I think, 9. All right, so slope, I'll use the letter m. And then once we do that, we have our point, we have our slope, we can get the equation of the line. So y minus 9 equals 9x minus 1. Now, don't get thrown. It's a coincidence that the y value is the same as the slope. I could have picked x2, right? So the y value is not always the same as the slope. It just happens to be that way this time. All right, now, that's the basic idea, but let's simplify that. So 9, this would be minus 9, then we add 9 to both sides. And so y equals 9x. So that tangent line is going to cross through the origin. All right, and this is kind of what I do with point slope form. I know I'm going to have to add 9 last step, and that's going to be added to the number that 9 multiplies here. So I just put those right there. And then I go jump to here. That's how I do that.